Okay, the last two parts of the last problem in 9.5. Find the 3 points where the absolute value of r is a maximum. Show that the tangent line is perpendicular to the line segment connecting the point to the origin. All right, so the first thing we do, and I'm going to go ahead and change the color just so it doesn't run into the other one. The first thing that we are going to consider is the absolute value of r is a max where, okay? And so we're going to look at our, sorry, I'm going to pull this up here so we can see our original problem. And it was the r equals 4 times the sine of 3 theta. So r equals 4 times the sine of 3 theta. So we know that the sine function is at a max at positive 1. Okay, and it says the absolute value of r, so that means we should consider positive 1 and negative 1. So we want to consider when this is positive or negative 1. That is when it's going to have the absolute value of r will have a maximum. See, this would multiply it by 4, so it's going to be positive or negative 4 at that point, the r value will be. So we can just go ahead and note that the absolute value of r is going to be 4, or absolute value of r equals 4 is a maximum petal length. Okay, because we know that the absolute value of the maximum for sine of anything, right? The sine of any angle goes from positive 1 to negative 1. So let's think about, on the unit circle, we know that the sine is positive 1 at pi over 2 and all of those things that land there, and at 3 pi over 2 and all of the other angles that land there. I know 5 pi over 2 also lands there, and then 7 pi over 2, and then we could also go into the negatives. So we're going to let this equal pi over 2, we're going to let this equal 3 pi over 2, and we're going to let this equal 5 pi over 2, okay? And each time if I divide by 3, for the first one I get pi over 6. If I divide by 3, the 3's cancel. The second one I get pi over 2. If I divide by 3, I get 5 pi over 6, okay? So I want to, because remember we were looking at this, this petal was sketched with my 0 to 2 pi, okay? So I'm only worried about 0 to 2 pi, and this gives me at least until pi. I might have more, but if I kept going, when does it happen again? What did we say? Was it 9 or 7? Because we've got 5, 6, 7, 8, 9. So if we did 9, we could keep going. But actually, now that I look back at this, it might have completed a cycle in 0 to pi radians. But anyway, let's just look at this. So our dy dx, so now our second thing is calculating your derivative at each one of these values. Okay, I'm going to do it first at pi over 6. So that's going to be my negative, negative square root of 3. And that is going to be perpendicular to the tangent of pi over 6 which is 1 over the square root of 3. And dy dx at pi over 2 is going to be 0, which is perpendicular to the tangent at pi over 2, which does not exist. And then dy dx at 5 pi over 6, which is going to be positive square root of 3, which is perpendicular to the tangent at 5 pi over 6, which is negative 1 over root 3. And of course, this could have also been written as square root of 3 over 3. This could have been written as negative square root of 3 over 3. And so, we're talking about, that one just took off. So for this one, we have a slope of the tangent is 0. At pi over 2. This one, we have slope of the tangent is negative square root of 3. I think my pencil might be going out. And for this one, we have slope of the tangent is positive pi over 3. And okay, so that's all I did for that part D. Find 3 points where R is at a maximum. So that's why I stopped there. You could have kept going with this 3 theta. Show that the tangent line is perpendicular to the line segment connecting the point to the origin. And so this one, it was perpendicular to that. This one was perpendicular to that. And this one was perpendicular to that. Okay? And then for part E, write the equation for the tangent line that passes through the point r theta equals 4 comma pi over 6. Okay, so my first thing would be thinking about my rectangular point at theta equals pi over 6. So 4 times the cosine of pi over 6, comma, 4 times the sine of pi over 6. And so my cosine at pi over 6 is going to be square root of 3 over 2. And my sine of pi over 6 is 1/2. So that gives me 4 root 3 over 2 comma 2. Oh, actually, I reduced my 4 times 1/2 to 2, but look, divide by 2 I get 1, divide by 2 I get 2. So this becomes 2 root 3, 2. Sorry about that. And then the next thing is we're going to look at the slope of the tangent at theta equals pi over 6. And we said our dy dx at pi over 6 is negative square root of 3. So now the third thing that we're going to do is find the equation of that tangent line. So y equals negative square root of 3 times x minus 2 root 3 plus 2. And if you wanted to, distribute, you'd have negative square root of 3x plus 2 times 3, 6, plus 2 would give you y equals negative square root of 3x plus 8. So either this one or this one works. And we're talking about this tangent line. And this was the point 2 root 3 comma 2. Oops. Sorry. 2 root 3 comma 2, this point right there. And this equation of the line, y equals negative root 3x plus 8. And that is it. I'm finally done with 9.5. I'm sorry I kept getting interrupted, but we finally